Hi guys, welcome to Math Side Trips, a channel for math teachers, students, coaches, trainers, and enthusiasts. Thank you for sparing time and effort to visit this channel. Many of the topics that have been discussed and will be discussed in this channel are those that are not usually taken up in mainstream classroom instruction. We hope that you will find in this channel something new, interesting, or useful. So this is our channel name, Mathematical Side Trips. I am Napoleon A. Gaking Jr., a math teacher. Now, discussion in this video will focus on the construction of equations in one variable, in particular, construction of polynomial equations. Linear equations in one variable with real coefficients and constant terms have real solutions. This is not true of polynomial equations of degree at least 2. For example, the equation x squared plus 4 equals 0 has solutions x equals 2i and x equals negative 2i, which are complex numbers. On the other hand, the equation x squared minus 2x minus 2 equals 0 has two real irrational solutions, x equals 1 minus the square root of 3 and x equals 1 plus the square root of 3. Thus, if the objective is to produce at least one real and rational solution, care must be taken in choosing the coefficients. The same unwanted solutions may result from equations involving radicals and equations involving absolute values. In this series of videos, different types of equations will be discussed, namely polynomial equations, equations from identities, equations from involving square roots, cube roots, fourth roots, and even absolute values. The topic on polynomial equations is highlighted because that is the subject of the present video. Okay, so the focus of the discussion is the construction of polynomial equations having at least one real and rational solution. Construction of linear equations is one of the easiest things that a mathematics teacher can do. As long as the coefficients and the constant terms are real numbers, solutions are also real, at worst irrational, but definitely not complex. For example, by writing out whatever coefficients and constant terms that come to mind, regardless of the number of terms appearing on either side of the equation, one may produce the following equation, which when solved gives x equals 123 over 206. Not a very nice solution. However, if some conditions are imposed, then construction requires a little more consideration. For example, if it is required that the solutions be rational or integers, then care must be taken in choosing the constants and coefficients. Haphazard or random construction would most probably result in equations that do not satisfy these requirements. In the method that will be discussed shortly, one still has the luxury of choice over the coefficients and constants even if some conditions are imposed. Moreover, it empowers the teacher to control the type of answers and the degree of difficulty of the problems. Take the number 12. Then the reflexive property of real numbers states that 12 is equal to 12, or any number is equal to itself. Now we can write either or both sides of the equality as linear combinations of distinct powers of any particular other number. For example, in terms of 3, we may have 4 times 3 on the left side, 12 on the right side, or maybe 5 times 3 minus 3, which is 12, or 2 times 3 plus 6, which is also 12, or 3 squared plus 3 times 3 minus 6 on the left side, and 7 times 3 minus 9 on the right side. Still we have 12 equals 12. Or 3 times 3 squared minus 7 times 3 plus 6 on the left side, and 3 squared plus 2 times 3 minus 3 on the right side. Still 12 equals 12. Now, replacing the 3 inside the parentheses with x, we have the first one is 4x equals 12. Then we also have 5x minus 3 on the left and 2x plus 3 on the right. We also have x squared plus 3x minus 6 on the left and 7x minus 9 on the right. And 3x squared minus 7x plus 6 on the left side, and x squared plus 2x minus 3 on the right side, each one of which has solution set containing 3. In the process of expressing either side of the equation as a linear combination of distinct powers of 3, and then replacing this particular number with a variable x, the solution x equals 3 has been embedded in the resulting conditional equation. Consider the equation 8 minus 3 plus 4 equals 9, and 4/3 plus 6 over 5 minus 3/2 equals 31 over 30. For now, we simply refer to the two preceding equations as seed equations. Now, embed a possible solution, say x equals 2. Then any of the numbers appearing in both equations can be written in terms of x. For example, from seed equation number 1, we have, among infinitely many other possibilities, the equations, these equations, 3, 4, and 5. In number 3, we have 5x minus 2, which is 8, since x equals 2, and x plus 1 is 3, because x equals 2, and 2 times 4 minus 2 is 4 on the left side. And then on the right side, 6 times 2 is 12, minus 3 is 9. So these equations come from the seed equations where we embed the solution x equals 2. Similarly, from seed equation number 2, we obtain these equations, number 6, 7, and 8. Still, the embedded solution is x equals 2. And we have two more, equations 9 and 10, which are now quadratic equations among an unlimited number of possibilities. Note that equations 3, 4, 6, 7 are linear equations, while 5, 8, 9, 10 are quadratic equations. Since corresponding expressions are distinct in appearance but equal in value, they may be interchanged to obtain additional equations. For example, if in equations 3 and 4 the corresponding first expressions are switched, we obtain two more equations, namely, these two equations. We have simply split 3x plus 2, switch, 3x plus 2 and 5x minus 2, obtaining two new linear equations. In fact, as mentioned earlier, since corresponding summands or expressions in equations 3, 4, and 5 are distinct in appearance but equal in value, there are a total of 3 times 3 times 3 times 3 equals 81 linear and quadratic equations. This is because we have 3 choices for the first expression, another 3 for the second, another 3 for the third expression on the left side, and we also have 3 choices for the expression on the right side. The amazing thing about all of these 81 equations is that they all have the common solution x equals 2. So far, we have only produced linear and quadratic equations based on the seed equations 1 and 2. However, if it is desired, equations 1 and equations of higher degree can also be constructed using the same method. For example, 3x cubed minus 4x squared, which is 8, because x cubed is 8, and 3 times 8 is 24, and then 4x squared is 16, so 24 minus 16 is 8, and then 2x squared minus 5 is 8 minus 5, which is 3, and then the third expression, 2x, is 2 times 2 is 4, so this is 8 minus 3 plus 4 on the left side, and on the right side, 4x squared is 16 minus 7 is 9. Same thing with the second equation, which is now a quartic equation. And we have two quintic equations. Okay. Again, since corresponding summands are distinct in appearance but equal in value, we have a total of 256 equations having different degrees. 4 choices for the first, another 4 choices for the second expression on the left side, and another 4 choices for the third expression on the left side, and 4 choices on the right side. When R is a solution of a polynomial equation, f of x equals 0, an easy trick to increase the degree n of f of x is to add 0, which is expressed in terms of x. So if m is greater than n, the degree of f of x, k is at least 1, and a is a constant, then the polynomial h of x, which is f of x plus a times x to the m plus k minus arx to the m plus k minus 1, has degree higher than f of x because m plus k is greater than n, and when x equals r, the new expression added to f of x is actually 0. Some advantages that the method possesses are the following: simplicity and convenience, control over the solution since they are predetermined and embedded somewhere in the construction, control over the degree of difficulty of the equations, availability of options to construct similar or parallel sets of questions, examinations, and 5, reduction of teachers' dependence on textbook exercises, examples, and examinations. That is all for now. We hope that watching this video was worth your while and that you found something new, interesting, or useful. Please click that subscription button if you want to subscribe, and hit that notification bell for updates about upcoming videos in this channel. God bless.